Azure Resource Manager, ARM, is the foundational service that allows for the provisioning and management of Azure resources in a highly organized and repeatable manner. It provides a consistent layer for deployment operations, enabling administrators to manage resources in groups rather than dealing with individual services in isolation. By leveraging ARM, each resource, such as virtual machines or storage accounts, can be tagged, versioned, and controlled through unified templates. This systematic approach reduces the risk of misconfiguration and fosters a predictable deployment pipeline. ARM templates, typically in JSON, define infrastructure elements, dependencies, and configurations. They ensure that resources are deployed in the correct order, respecting interdependencies automatically. For large-scale solutions, ARM helps maintain coherence across various services by grouping them into resource groups controlled by role-based access policies. Its integration with policy definitions further guarantees compliance. Administrators, therefore, gain a standardized, secure, and consistent framework for orchestrating cloud environments using code. Bicep is a domain-specific language, DSL, that streamlines infrastructure as code efforts on Azure. It reduces the verbosity typically associated with JSON-based Azure Resource Manager templates, making deployments more accessible and maintainable. Built by Microsoft, Bicep provides a more natural syntax akin to modern programming languages, allowing for modular and cleaner code. With Bicep, advanced features like parameter declarations, variable assignments, and resource definitions require fewer lines of code. Despite its more elegant syntax, Bicep compiles down to a standard ARM template format under the hood, ensuring complete backward compatibility. This means that existing deployment pipelines that rely on ARM remain fully valid. Bicep also enables features like symbolic references, making it easier to refer to resources across your entire template without manually managing complex resource IDs. By concentrating on clarity, Bicep helps operators and developers better understand, maintain, and scale Azure deployments without sacrificing any capabilities offered by ARM. Although both Azure Resource Manager templates, ARM, and Bicep achieve similar goals, provisioning and automating Azure infrastructures, each has distinct characteristics. ARM templates are written in JSON, a format known for strict syntax rules and verbosity. These templates often become lengthy, making them prone to typographical errors and complicated maintenance. Bicep, on the other hand, provides a more concise syntax. It offers constructs such as reusable modules, symbolic references, and simpler parameter definitions to reduce clutter and enhance readability. Bicep code compiles to a standard ARM template, preserving all existing deployment workflows. Moreover, working with Bicep eliminates many of the bracket matching challenges found in JSON-based ARM scripts. The language also facilitates an easier approach to referencing resources across files or modules, supporting more organized code structures. While both approaches rely on the same underlying deployment engine, Bicep's abstraction often expedites the authoring process, decreasing development overhead. Both ARM and Bicep templates follow a logical structure to streamline deployments. In an ARM JSON file, core elements typically include parameters, variables, resources, outputs, and sometimes functions. Each resource is defined by its type, name, and properties, along with dependencies to ensure correct deployment sequencing. Bicep follows a similar structure but implements a more streamlined representation. Here, parameters are declared using succinct syntax, immediately providing a clearer view of required inputs. Resources can be referenced symbolically, bypassing the need for manual management of complex resource IDs. For example, Bicep Resource Storage Microsoft storage/storage accounts at 2021-02-01 equal then. Mr. Ajax location, resource group, .location. In this snippet, the resource keyword defines a storage account, specifying its full resource type and version. This concise format enhances readability and maintainability. Understanding these core elements lays the groundwork for effectively interpreting more complex templates. Parameters and variables are key to making templates adaptable and reusable. In ARM, Parameters are declared in the parameters section with a name, type, and optional default value. These parameters can be used throughout the template to set resource properties like names, sizes, or locations. Variables are similarly declared in the variables section, allowing for more complex constructs or computed values. Bicep adopts a comparable approach, but with more straightforward syntax. A parameter might be declared as Bicep param admin username string equals Azure user and used to configure a virtual machine's admin account. Variables in Bicep are defined via the var keyword for intermediate calculations, such as combining parameter inputs to generate a resource name. By centralizing values in parameters and variables, both languages promote configurability and enable the same template file to be used across multiple environments or projects. Resources are the foundational elements defined in a template, specifying services like virtual machines, storage accounts, and virtual networks. They include configuration details, such as size, tier, and location. Dependencies manage sequencing, ensuring one resource deploys before another if needed. In ARM JSON, dependencies are typically declared in the depends on property of a resource. Bicep employs a similar mechanism, but leverages symbolic references, allowing the use of resource names directly rather than specifying the underlying resource IDs. For instance, Bicep resource MyVNet Microsoft network/virtual networks at 2021-02-01 equal name. MyVNet resource MySubnet Microsoft network/virtual networks/subnets at 2021-02-01 equals n. MySubnet parent. MyVNet in this example. The subnet resource references its virtual network parent through a simpler construct. By clearly organizing dependencies, administrators ensure that Azure deployments happen in a logical, error-free order. In certain scenarios, multiple instances of a resource must be created or deployments should proceed only under specific conditions. Both ARM and Bicep offer constructs to handle these requirements effectively. For iterative deployments, ARM templates use copy loops, where developers declare the count and name for repeated resource elements. Bicep implements a similar pattern using the for keyword, allowing resources or properties to be defined in a concise loop. Conditions let you decide whether a resource or module should deploy based on a Boolean expression. For instance, you might only deploy a public IP address if the parameter createPublicIP is set to true. This dynamic approach ensures a single template can meet various environmental needs. In Bicep, you might wrap a resource definition in an if expression, ensuring it deploys only when conditions are met. Such flexibility is central to constructing robust, environment-agnostic infrastructure code. Functions serve to simplify logic within templates, reducing repetition and enabling consistent transformations. ARM templates provide built-in functions like concat, to lower, or resource ID, alongside more complex ones for string manipulation or numeric operations. Bicep offers the same range of functions, simply wrapping them in a more streamlined syntax. For example, one might calculate a fully qualified domain name, FQDN, by concatenating the VM name with a predefined DNS zone. Functions can also handle conditions, arrays, and object structures, yielding dynamic resource configurations. A typical usage might look like Bicep var vim lower equals to lower perm VM name, var final name equals concat, VM name lower, VM. These transformations keep the code concise while ensuring consistent naming or parameter handling. Functions also facilitate inline deployment logic, generating resource-specific values on the fly without requiring extensive external scripting. By providing a comprehensive function library, ARM and Bicep minimize complexity throughout the deployment process. Once templates are ready, they can be deployed through various methods, including the Azure CLI, Azure PowerShell, or the Azure portal. In the Azure CLI, an ARM template can be deployed with a command like bash AZ deployment group create / resource group my resource group / template file template.json / parameters at parameters.json for Bicep. The command structure remains nearly identical, except the template file references AZ-Bicep extension. Developers and administrators can also leverage CI/CD pipelines in Azure DevOps or GitHub Actions to automate deployments, integrating version control and testing processes. When a Bicep file is submitted for deployment, it is automatically transpiled into ARM.json. Through these approaches, the entire infrastructure configuration can be versioned, tested, and reliably replicated, enabling robust DevOps practices. Properly orchestrated deployments enhance consistency across staging, production, and disaster recovery environments. Monitoring deployments and diagnosing problems are crucial aspects of a robust infrastructure strategy. Azure offers extensive diagnostic and logging tools, including the activity log to track resource level changes and resource health for real-time status reports. Tools like Azure Monitor provide unified metrics and logs, enabling administrators to quickly identify bottlenecks or configuration errors. For ARM or Bicep templates, deployment logs within Azure Portal or the CLI provide the outcome of each provisioned resource, detailing any failures. By reviewing these logs, one can determine if a dependency was improperly declared or if a parameter value caused an unsupported configuration. Additionally, advanced debug options can be enabled for more granular outputs, especially in complex or multi-step deployments. This transparency helps teams pinpoint mistakes, correct them rapidly, and maintain reliable, repeatable processes. Overall, diagnostic features and logging capabilities reinforce the stability and traceability of Azure infrastructure deployments. Modular design allows administrators to break large-scale deployments into smaller, reusable operational units. Bicep, in particular, supports modules that encapsulate resource definitions for focused usage. For instance, a module might define a storage account setup with certain security constraints, which can be easily invoked across various environments. The same principle can be adapted in ARM by referencing external templates, but Bicep simplifies the syntax and promotes a more streamlined approach. This modular technique not only promotes code reuse, but also isolates responsibilities so that changes in one module do not inadvertently affect other parts of the architecture. In Bicep, modules can be stored in a central repository, making them accessible to your entire team. By adhering to standardized naming conventions and parameter definitions, organizations can create a library of well-tested patterns, ensuring consistency in infrastructure deployments. Such structured methods increase maintainability and diminish complexity over time. Security and governance measures are integral when creating Azure infrastructures at scale. ARM and Bicep integrate seamlessly with Azure policy, allowing organizations to control which resources can be deployed and enforce configurations. For example, policies could ensure that only VMs of a particular size or within certain geographic locations are permitted. Role-based access control, RBAC, fortifies the management plane by restricting who can deploy or modify resources. Templates secure sensitive information using features like key vault references, preventing credentials from appearing in plain text. Encryption at rest configurations and network isolation can also be codified, ensuring compliance with organizational or industry standards. Furthermore, compliance frameworks, such as HIPAA or ISO 27001, can overlap with policy definitions, verifying that newly deployed resources do not violate mandated rules. By embedding these governance practices into ARM or Bicep templates, administrators achieve consistent, automated enforcement of security requirements throughout the entire resource lifecycle. Effective use of ARM or Bicep templates stems from a set of established best practices that ensure cleaner, more maintainable code. Storing templates in a shared version control system ensures traceability, enabling rollbacks in the event of misconfigurations. Adopting expressive naming conventions for parameters, variables, and resource identifiers promotes clarity across your environment. Using modular files, especially with Bicep modules, drives reusability and prevents bloated singular templates. Integrating unit or syntax checking as part of a continuous integration pipeline bolsters code reliability. For example, running the Bicep build command to validate your file can catch errors early. Additionally, specifying strict parameters in the template ensures that only valid inputs are deployed, reducing runtime failures. For large deployments, consider employing nested templates or modules to logically separate subsystems. Monitoring logs for each deployment step further refines the process, guiding incremental improvements over time for more scalable, robust Azure solutions.